Hello. Good morning, dear students. How are you all? This video lesson module number 9 on metals and non-metals brought to you by Vignan Global Gen Schools, Hyderabad. I, myself, Reddy.P, teaching faculty. Dear students, in the previous module, we have learnt about extracting metals of low reactivity, extracting metals of moderately reactivity, and extracting metals of high reactivity, along with thermit reaction and refining of metals. And we even discussed about electrolytic refining of copper. Now, today, especially in this module, we are going to learn about corrosion of metals, corrosion of the metals. So, without delay, let me start the session. Okay? So, what is the topic meant for today? Corrosion, C-O-R-R-O-S-I-O-N, corrosion of metals. Corrosion of metals. Yes. Now, in this module, we'll discuss about what is meant by corrosion, what are the conditions necessary for rusting of iron with experimental verification, and what are the prevention methods, what are alloys, how they made, and few alloys which we are using in our day-to-day life. Yes, these are the subtopics or concepts which are meant for today. Now, corrosion of metals. Let me take three metals which are quite familiar to you in our day-to-day life. Now, I am giving the first clue for first metal. This metal play very tremendous role or prominent role in the construction industry. What is that? Iron. Yes, you are correct. What is that? Iron metal. And next, copper. Copper, because we are using copper vessels, especially for cooking purpose. Okay. And jewelry purpose, one important metal is there. What is that? Silver. We are using silver utensils also. Okay. These three metals we are taking. Now, let me take iron. Yes. Iron. What is the symbol? Fe. When you kept iron metal or iron article in the open atmosphere for considerable time, then what will happen? What is your observation? Yes. Now let me teach. This iron nail or metal or article kept exposed to the open atmosphere like this. This iron metal or article slowly picks up oxygen from the atmosphere, and moisture means H2O, and develop one type of coating, unwanted coating. And what is the color of this unwanted coating? Reddish brown. What is the color of this coating? Reddish brown, and is called rust. What is the general name of this reddish brown coating? Rust. So this rust is unwanted layer which is brown in color. It is like a flaky substance, and this process is called corrosion of iron. What is that? Corrosion of iron, especially rusting of iron. Rusting of iron. Now let me take the equation. Iron reacts with oxygen in the presence of moisture, H2O, gives rise to Fe2O3 XH2O. To balance this chemical equation, so for suppose if you put here 2, then iron become 4 and O become 3O2, and here 2XH2O. Okay. So this is about the balanced chemical equation for rusting of iron. And this substance formed at the end is called rust. The color of rust is reddish brown, brown flake substance. And like this iron, the second important metal, copper, also undergo corrosion. Yes. Copper undergo corrosion. Copper slowly picks up carbon dioxide and moisture from the atmosphere. So, copper particles slowly picks up carbon dioxide and moisture from the atmosphere. And finally, they develop, or copper particles develop, a green coating. What is that coating called, my dear? Green coat. And this green coat is due to the formation of basic copper carbonate. What is that? Basic copper carbonate. And what is the formula of basic copper carbonate? CuCO3 dot CuOH twice. So in this way, copper particles also undergo corrosion and to develop a green coating. And what is the name of this green coating? Basic copper carbonate. Okay, and this is the formula, CuCO3 dot CuOH twice. In the similar way, let me take the third element, silver. Silver also undergo corrosion. Silver specially picks up sulfur compound present in the atmosphere. What is that? Hydrogen sulphide. Silver particles, and the particles made up of silver picks up one sulfur compound from the atmosphere. What is that? Hydrogen sulphide. And finally develop a black coating. What is that coating? A black coating. And this black coating is due to the formation of silver sulphide. Silver sulphide. Yes. So this is about the corrosion of silver. So silver particles develop black coating, and this black coating is called silver sulphide. Okay. So this is about corrosion of iron, corrosion of copper, corrosion of silver. And now let me define what is corrosion by observing these phenomena. Yes, very simple. Without any confusion, try to define. This is a process in which metals are eaten up gradually by the action of air, moisture, and different types of acidic gases or gases from the atmosphere, and finally develop different dull coatings with different colors, different dull coatings with variation of colors, and this phenomenon is called corrosion. And you said that metal is corroded. That metal is corroded. And if you take the best example for corrosion, rusting of iron. So whenever if you want to say rusting is exclusively meant for iron particles. And if you want to express about copper and silver, you have to use the word corrosion. Copper particles undergo corrosion, silver particles undergo corrosion. Okay, my dear students. So this is about corrosion of metals. So what is the reason for this corrosion of metals? Because you know, metals are reactive. Metals react with different type of gases and different components present in the atmosphere time to time. And this is one of the reason for corrosion of the metals. Okay. Now, after this corrosion of iron, copper, silver, let us go for rusting of iron. What is that? Rusting of iron. So, shall I rough this one? Rusting of iron. Okay. Now, let us verify or investigate What are necessary for rusting of iron? This is a kind of investigation specially prescribed in our textbook in the form of activity. What is that? This is about investigating the conditions for rusting of iron. So, conditions, what is that? Tell me once again. Conditions that are necessary for rusting of iron. Conditions necessary for rusting of iron. Let us investigate with the help of one activity. Yes. For this activity, we require some materials, some apparatus. What are they? First, I will require 3 test tubes. So, test tube 1, test tube 2, and the third one, test tube 3. 3 test tubes. Okay? And each and every test tube, let us keep few iron nails in each and every test tube. But see that the iron nail is clean and neat. Very clean, neat iron nails we are keeping in the test tubes like this. So, this is about first iron nail, second, and here also first iron nail, second, and here also we are taking 2 iron nails, clean and neat. And these are called iron nails. Fe, iron nails. Okay. So this is about, and label them as test tube A, test tube B, test tube C. Okay. So take 3 test tubes and insert or keep 2 or 3 clean, neat iron nails in them and labeled them as A test tube, B test tube and C. Pour some water in test tube A. So test tube A consisting of what, my dear? Water. And cork it immediately. Cork it, yes. We even provide the cork. Pour some water in test tube A. Pour some distilled water, hot distilled water in test tube B. So what is this? Hot distilled water. Hot DW. DW means distilled water in test tube B. And along with this hot distilled water, pour 1 ml of oil. Pour 1 ml of oil so that this oil floats on the surface of water as a layer and cuts short the supply of air. And cork it immediately. Yes, we are providing even cork also like this. And in third test tube C, we are neither providing water nor oil, but we are providing anhydrous calcium chloride. What is this? Anhydrous calcium chloride in test tube C. So what is the role played by this anhydrous calcium chloride? It absorbs moisture from the air present in test tube C. It absorbs moisture and it is a drying agent. And this nature is also called hygroscopic. What is the nature name? Hygroscopic. So what is this substance name? Anhydrous calcium chloride. And again cork it. Yes, we are providing cork. Now once you observe, my dear students, test tube A consisting of water, test tube B consisting of hot distilled water along with iron oil, along with oil layer. This is called oil. and test tube C consisting of anhydrous calcium chloride. Now, I am just asking one question. Out of the 3 test tubes, in which test tube rusting takes place? Rusting takes place. So, out of the 3 test tubes, in which test tubes rusting takes place? Yes, your answer is correct. In test tube A, rusting occurs. Rusting takes place. In test tube B, rusting does not take place. In test tube C also, rusting does not take place. Why? Why in test tube A? Because in test tube A, both the conditions are present. One is air consisting of oxygen and moisture in the form of water. That's why rusting takes place. In test tube B, water is present, moisture is present, but there is no place for oxygen. Because your oil layer is there, which cuts short the supply of air. That's why one condition is present, one condition is absent, rusting does not take place. And what about test tube C? In this test tube, air is present, but there is no place for moisture. Because whenever some moisture is present, that is taken out by anhydrous calcium chloride. So air is present, water is absent or moisture is absent. That's why rusting does not take place. So from this activity, what is the conclusion drawn or what is the inference drawn means rusting takes place in the presence of air and moisture. The necessary conditions for rusting of iron are, what are the 2 conditions? One is oxygen, especially from air, and the second one is moisture. What is the second condition? Moisture. These 2 conditions are necessary for rusting of iron articles. So with this, we have ended up the discussion related to this activity, investigation. This is investigation type of activity. Investigating the conditions necessary for rusting of iron. Now, after getting the iron and how to prevent this rusting, how to prevent? Is there any prevention methods in order to avoid this rusting? Yes, there are prevention methods. We already learned these things in chapter 1. What is the first prevention method? By oiling, by painting, by greasing, by chrome plating, by anodizing, and by galvanization and alloying, we can prevent rusting of iron. Okay? So what are the methods once again? Oiling, painting, greasing, alloying, chrome plating, anodizing, and galvanization. Do you know what is meant by galvanization? Yes. In this method, iron and steel objects are protected against rusting by coating with zinc metal. So, we are dipping iron articles in zinc metal. Then automatically one layer is obtained, one layer is formed, zinc layer. And zinc is high resistant to corrosion. But whenever this zinc layer is breaking, iron articles do not undergo corrosion. Iron articles do not undergo, galvanized articles do not undergo corrosion or do not undergo rusting even if zinc coating broken. Why? Did you understand my question? Even if you break the zinc coating, galvanized articles never undergo rusting. Why? This is because zinc is able to react with oxygen very quickly compared with iron. So because zinc is more reactive than iron, zinc is able to form the zinc oxide layer. And for suppose if this zinc oxide layer is breaking, again zinc is able to form zinc oxide layer. So in this way, zinc undergo corrosion, but the iron present underneath the zinc will save. Okay, and later, even though this iron, if you take iron articles undergo corrosion, but is there any process to develop this one or to develop special properties, to improve the special properties? Yes, there is a process. And iron, if you are mixing metals with metals, definitely improve their properties. If you want to improve the properties of metals, you have to mixing one metal with the other metal, and you will get some desired properties. For suppose, now let me take iron metal. You know, this iron is most widely used metal, but we are not using pure iron. Yes, iron is mostly used metal, but we are not using pure iron. Why? Because pure iron is very soft and stretchable when hot. Yes. Why we are not using pure iron for construction purpose? Because pure iron is very soft and stretchable when hot. Then what we will do? This iron alloyed with carbon 0.05%, and you will get one alloy. What is that alloy called? Steel. And what are the properties of steel? This is hard. Steel is hard and strong. Steel is hard and strong. So you need to alloy this one with 0.05% of carbon. Then you will get to steel. What is the advantage of steel compared with iron? Means steel is hard as well as strong. Okay. But now, if you are adding two more elements to steel, this is steel. Now I am adding chromium and nickel. You will get few more properties. What are they? High resistant to corrosion. Resistant to corrosion and strong. Yes, these properties developed. What is that? High resistant to corrosion and strong. And what name is given to this alloy? This is called stainless steel. What is the name of this alloy, my dear? Stainless steel. So first we are taking iron. Pure iron is actually not for industry. Why we are not using? Because it is very soft and stretchable when hot. That's why we need to alloy this iron with 0.05% of carbon to improve hardness and strength. And if you add chromium and nickel metals to steel, then these properties again improved. So that you will get stainless steel, and stainless steel articles are high resistant to corrosion. Where we are using these stainless steel articles? Watch springs, watch dials, in cutlery, kitchen purpose cutlery, and surgical instruments. For this purpose, safety razor blades, all these made up of stainless steel. All these are stainless steel articles which are high resistant to corrosion. And in this way, we will develop one method that is called alloying. What is that method called? Alloying. My dear students, now tell me, what are alloys? Very simple. We already learned this one in previous sections. What are alloys? A homogeneous mixture of metal and metal, or a metal and non-metal. A homogeneous mixture of metal and metal, two or more metals, or a metal and non-metal are called alloys. How they made? Alloys are made by melting the primary metal and dissolving the other metals in definite proportions, and cool this total mixture to the room temperature. Once again, how you are able to make alloys? By melting the primary metal and dissolving other metals in definite proportion and allow to cool the total mixture to room temperature. In this way, you can make the alloys. For suppose, there is an alloy which is called amalgam. Here, one alloy is there. What is the name of that alloy? Amalgam. Amalgam. What are amalgams? Yes, an alloy of mercury. An alloy which consisting of mercury is one of the element is called amalgam. What is the main use of amalgam? To fill the cavities of the teeth. It is very useful in dentistry. For suppose silver amalgam, gold amalgam, you are generally used to fill the cavities of the teeth. And for suppose if you take brass, B-R-A-S-S, one alloy is there, brass, and whose composition is copper and zinc. Two metals are present in brass. And one more alloy is there, bronze. What is that? Bronze. And here also two elements are there, two metals, copper and tin. This combination is called bronze. So what are the main uses of brass and bronze? These two alloys are find many applications in our day-to-day life. Statues, medals, and strings of sitar and guitar. So some decoration articles. All these are made up. Coins are made up of this brass and bronze alloys. But this brass and bronze alloys electrical conductivity is less than pure copper, whose melting points are less than pure copper. So there are two characteristic properties for alloys. What are the two characteristic properties? First one is low electrical conductivity, and second property, low melting points than pure metals. So in this way, brass and bronze have low melting points and low electrical conductivity than pure carbon. In this way, brass and bronze differs with pure copper. And you know, one more alloy is there whose name is another alloy is there whose name is, what is that? Now I am writing here another alloy. What is that name of that alloy? Tell me. Solder. Yes, another alloy, solder. And the solder alloy is the combination of lead, Pb, and tin, Sn. What is the symbol of tin? Stannum, Sn. And this solder find application and where you are using. This is used in welding purpose. Welding. This alloy is used to weld the electrical wires. Welding of electrical wires. And this solder alloy has low melting point. Low melting point. So, which property make solder alloy useful for electrical connections? What is that property, my dear students? Low melting points. Yes, this is about the alloy solder. Now coming to gold. My dear students, you know about pure gold. What is pure gold? 24 carats gold is called pure gold. But we are not using pure gold for ornaments. Why? Because this is very soft and stretchable. Pure gold is very soft and stretchable. That's why we need to alloy this gold with 22 parts of gold with 2 parts of either silver or copper. So we need to alloy this pure gold with 2 parts of either silver or copper to get hardness. And that gold is obtained by this process is called 22 carat gold. In our country, we are using 22 carats gold, which is called ornamental gold for making jewelry. ornaments. Okay, and these things are there in this today's module, my dear students. With this, I have successfully ended up this total, what is that, metals and non-metals. So before going to end up this module, let me take 1 or 2 minutes in order to recapitulate. Now, the necessary conditions necessary for rusting of iron are 2. What are they? Oxygen and moisture. For that, one activity is there in our textbook, that is called 3 test tube activity. In first test tube A, rusting takes place. Why? Because in first test tube, moisture is present along with the air, and remaining 2 test tubes, there is no place for rusting. And there are few prevention methods are there. How to prevent rusting of iron means oiling, greasing, alloying, electroplating, chrome plating, anodizing. These methods are there. In all these methods, galvanization is one of the advanced method. What is meant by galvanization? Yes, iron and steel articles are protected against rusting by coating with the zinc metal. What is the need for us to implement alloy system to get desired properties, to get special properties? For this, we need to develop the system of alloys. What are alloys? Homogeneous mixture of 2 or more metals, or a metal and non-metals. Alloys are prepared by melting the primary metal, dissolving the other 2 metals or 3 metals in required proportion, and cool the total mixture to the room temperature. And the main constituent present in steel are iron and carbon. Stainless steel, iron, carbon, chromium, nickel. And what about brass? Brass consisting of 2 metals, copper and zinc. What about bronze? Copper and tin. What about solder? Solder consisting of lead and tin, which is used for welding electrical wires because of its low melting point. What is amalgam? An amalgam is an alloy of mercury. So in any alloy, if element mercury is present, that is called amalgam, which is used to fill the cavities of the teeth. So this is about details of this today's module, my dear students. So we will definitely meet in another module with a new chapter. Till then, my dear students, have a nice day. Thank you.